In this lecture, we're going to look at some examples of how we can use the properties of the angles that are formed when a transversal cuts two parallel lines to fill in a lot of the missing angle measures if we have just a little bit of information. So what we're told here is that the two lines that look parallel, line L and M, are parallel. And we're given the information about one of the angle measures. We know that angle 2 is 61 degrees. We want to find the measures of all of the other angles. Well, the way I do these diagrams is I just start filling things in, right? For example, I know that angle 2 is 61 degrees, so I'll write 61 degrees right here by that angle. Okay, now what else do we know? Well, I know that angle 2 and angle 6 are corresponding angles, and corresponding angles are congruent, so angle 6 must be 61 degrees. And I know that angle 2 and angle 3, they form a line if you put them together. So those two angles must be supplementary. So angle 3 is 180 degrees minus 61 degrees, which is 119 degrees. Then we can use the exact same angle the exact same argument down here for angle 7, or we could point out that angle 3 and angle 7 are also corresponding angles, which means that angle 7 also has to be 119 degrees. Right now, I know we haven't even touched the left-hand side, but at this point, we're pretty much home free. Angle 3 and angle 5 are alternate interior angles. Alternate interiors or angles are congruent, so this one must be 119. Similarly, angle 4 and angle 6 are alternate interior angles. So angle 4 is 61. Finally, angle 1 is a corresponding angle to angle 5. So this is 119. Angle 8 is a corresponding angle to angle 4. So that one has to be congruent and 61 degrees as well. And there you go. Right? We've filled in this entire diagram just based on two pieces of information. The lines are parallel and one angle measure. So there's a little more going on here. We have four lines, two parallel lines again, L and M. And this time we have not one, but two transversals. Okay, so I'm going to do the same thing I did before. I'm going to fill in the information that I know. Angle 14 is 47 degrees, and angle 11 is 36 degrees. Well, based on those same supplementary relationships, 11 and 12 are supplementary, which means 12 is going to be 180 minus 36. That's 144 degrees. Similarly, angle 13 and 14 are supplementary. So 13 is going to be 180 minus 47, which is 133 degrees. All right, so now I can kind of walk around both of these circles, right? Because 8 and 13 are supplementary. Angle 8 is 47, and angle 7 and 8 are supplementary, so 7 is 133. And we can do the same thing down here with angles 9 and 10. Angle 10 is 144, and angle 9 is 36. Now, to fill in the top, I'm going to start looking for relationships based on the parallel lines. Angle 6 and angle 8 are alternate interior angles. Those are congruent, which means angle 6 is going to be 47 degrees. What else do we know? Angle 3 and angle 8 are corresponding angles, so angle 3 is going to be 47 degrees. Now, if you look closely here, angle 4 and angle 9 are alternate interior angles formed by this transversal, which means they're going to be congruent, which means angle 4 has to be 36 degrees. All right, so now we can get angle 5. Angle 4, 5, and 6 together are a line. That's 180 degrees. So the measure of angle 5 is going to be 180 minus 47 minus 36 minus 47 minus 36. That's 83. 83 minus 180 minus 83 is 97. So that gives me angle 5. Now, we can keep working our way around using this exact same argument. Or we can take a little shortcut. Angle 1 and angle 9 are corresponding angles. Right? So they have to be congruent. That means angle 1 is going to be 36 degrees. Now we can do 1, 2, and 6. They're going to have to add up to 180. So 2, if you do the arithmetic, is going to be 97 degrees. And that fills in all, however many. How many were there? All 14 of these angles. All right, so in the next lecture, we're going to kind of continue this process, right? You notice what we've been doing here. We started off with single lines. And we said, okay, what if I have two lines but they cross? And I said, okay, well, what if I have two lines and they don't cross? Well, what if I have two lines and they don't cross and I add a third line that cuts across the two of them? Well, in the next lecture, we're going to say, okay, well, what if we have three lines, right? Three lines that all cross at different points, right? And what we're going to do here is we're going to say, okay, we're really going to kind of strip away all the exterior stuff and just look at this part here, and we end up getting a triangle.